All right, so here we have arrived at the SOPs chapter, or surface operators and modeling chapter. So we're going to be, doing a deep dive into SOPs and learning about how we can use the SOPs context to, build some cool stuff. Initially, we're going to, go over some. I'm just going to explain sort of some Houdini geometry terms so we can get on the same page with regards to that. And then we're going to talk about kind of moving geometry around and how to kind of manipulate it just by, standard modeling workflows. And then we're going to get into talking about groups, and then we're going to do some digital asset creation and create some fun modeling examples using volume meshing and Boolean, Voronoi, all sorts of cool stuff. So the first thing I wanted to cover, just so that we can all get on the same page, is Houdini geometry and what all that means. To do that, I'm just going to throw down in an empty project here. I'm going to just throw down a grid. Now, don't feel like you need to follow along. This is more or less just an overview so that we can, be all on the same page. I'm going to jump inside the grid. I'm going to change the rows and columns to 3 and the size to 1 by 1. So we get this grid with 4 polygons right here. So cool. So now you can see as I'm hovering over each one of these faces or polygons, you can see that they're being highlighted. Now, if I go over here, you can see that my selection mode is set to primitive mode. Primitive mode is referring to primitives, and primitives are, according to the Houdini docs, a unit of geometry. And these units can be represented in a number of more advanced ways than what we're going to be covering right now, such as volumes can be primitives, polygon soups can be primitives, impact primitives can be primitives. These are all, more advanced ways of representing geometry, but for our purposes, a primitive for right now is just a polygon. So if I go over here on the right-hand side where you can see our different visualizers, you can see that I've got this this number 1, 2 with a little square underneath it. If I click on that, you can see our primitive numbers appear here in pink over each polygon. So we've got 0, 1, 2, and 3. Great. So that's sort of where we are with primitives. Primitives, when I'm referring to primitives, we're basically going to be talking about polygons mostly for this section. Cool. So what makes up a primitive? Well, a primitive, it has a bunch of edges and it has a bunch of points and a bunch of vertices. So what are the differences between points and vertices? So I'm going to click this button right here. This is to display points. You can see that they appear in blue, and it looks like we've got 9 points. If I turn on these numbers, you can see that it numbers those points accordingly. See, we start up at 0 here, and we go 1, 2, 3, 4, 5, 6, 7, 8. So from 0 to 8 is 9 points. A point is represented of a corner of a primitive, really. And so we've got points, and we can manipulate points and use that sort of to define the positions of the vertices of our primitives. So what's the difference between points and vertices then? So while a primitive can have, 4 points to it, it's sharing these points with, another primitive, for example. And this point right here is actually being shared by 4 primitives. Whereas this point represents a position in space, a vertice actually represents the position of the corner of the polygon, and it is defined by that point in space. So if I turn on vertice visualization, you can see down here in this corner, there's just one vertice corresponding to this one point, and those are both kind of sharing the exact same space. Over here, you can see that there's 2 vertices, one for this primitive and another for this primitive. And those are both sharing this point number 5 location in space. And then, the most extreme example in this view is these 4 pink vertices in the middle that are all being shared by this. They all sort of share the same location as point number 4 in 3D space. So now, because all of these polygons are connected, these points, they're represented as being shared. So if I throw down a facet SOP, and I just wire this in and choose something like unique points, and I'm going to display that, you can see the point number kind of jumps up. We've got some overlapping numbers here. I'm just going to illustrate this by throwing down a primitive SOP. And the primitive SOP is just going to allow me to sort of shrink each one of these polygons. If I check do transformation, I'm just going to scale each one of these down a little bit so you can see that now we have pulled apart each point and more or less just assigned it to the position of the vertices. So all the vertices and all the points are unique at this point. So it's a subtle difference, but it's, for our purposes, we're mostly going to be doing manipulation of points. Not so much vertices, but it's important to know that they're there and what the distinction is between them. Vertices make up polygons, and vertices are located at points in space. We can change those points in space to define where the vertices that make up our polygons are going to translate to. It's a very subtle distinction, but it just comes up quite a bit when you're doing this stuff. So it's important to kind of know what the difference is. So other aspects of Houdini geometry, I'm going to just throw down a torus here. And I'm going to just zoom back out, and there's a lot going on here. So I'm going to just turn off these visualizers and turn off this. So you can see we've got our torus geometry here. I just wanted to quickly go over what normals are. So normals you may be familiar with. They're kind of the things that point out of the geometry to sort of represent what angle the geometry is facing in, and it helps with all sorts of stuff like shading and determining where specular highlights like this are going to be, where shadows are going to be, etc. When you're shading an object. So I'm going to just turn on my normals visualizer right here. So if I click that, you can see that we get all these little green spikes sticking out of our geo. And if I zoom in, you can see that there's actually many little tiny normals sticking right out of this point. And basically that's representing the fact that there are 4 vertices here. So you can see very closely there are 4 normals sticking out, and it's defining a different normal for each vertex of the 4 polygons that are joining right here. And so if I were to throw down a normal SOP, you can see that it's going to kind of give us the option to determine where the cusp angle happens between these vertexes. So you can see that anything, any angle that is less than this 60 degrees is going to be determined to be a hard edge, whereas if it's greater than 60 degrees, like here, this right here is a pretty wide angle between, these two edges. Between these two polygons is a pretty wide angle, so it's not going to be cusp. If I were to bring this value down, you can see that we start to get these nice hard edges. And if I turn off smooth shaded, you can see that we get that kind of Virtua Fighter Sega look to our geometry. So that's sort of what those are. Now we can also, like how we have these vertex normals, we could also do point normals. Point normals are just a representation of the 4 vertex normals being sort of combined together into one. And so when we get this option, I don't really have the option to cusp anything at this point. It's just literally doing, it's literally just taking, I think, an average of those 4 normals. So just important to note, so we can have point normals and we can have vertex normals. Vertex normals, if we switch back to vertex normals, allow us to do different cusping and stuff like that, determining hard edges. And you can see that when we do these nice hard edges, all of these normals are, for example, for this polygon, all these normals are sort of aligned perpendicular to the face, whereas when we bring the cusp angle up, they actually sort of average to the angle between the faces. So that's just a important thing to keep in the back of your mind as we move forward and start working with manipulating normals and such, because there's going to come points in while we're working with Houdini geometry where we're going to want to do something like, say, have a bunch of point normals, and then we're going to want to say we displace geometry along the normal, or use the normal to determine what direction the geometry is facing, so we can maybe select a group of polygons only facing upward. So that'll come into play in a later example, but it's just important to kind of know these things going in, just so that it's not completely alien to you when we get in there. Yeah, I know that this does seem probably pretty basic at this point, but the thing that I've heard time and time again from users who are learning Houdini is that having come from a different app like Cinema or something, Houdini is really, almost enlightened people in a way to get a deeper understanding of how 3D is actually working behind the scenes and what it is that makes their programs work, like Cinema 4D. A lot of this stuff you don't really need to know if you're working in Cinema 4D, but it certainly helps. And in Houdini, you really do kind of need to know what this stuff is to do the cool things that Houdini can do. So that's sort of an overview of all these things, and I just wanted to kind of give you an example of what these things are, so that we can sort of all kind of be on the same page, speaking the same language as we move forward. So in the next lesson, what I'll do is I'll give you kind of an overview of how we can grab and pull and manipulate some of this geometry in the viewport and in the network editor, and how those two correlate with one another. So I'll catch you then.